I'm Ted Olson. I'm the CEO of Aqualith Advanced Materials. Here at Aqualith, we've built a business for consumer electronic aficionados who want to spend less time charging their devices. We make revolutionary materials for lithium-ion batteries. We don't make the batteries, we make the materials. And we do that so that all of us can spend more time enjoying our lap phone, smart speakers, electric vehicles, you name it, as opposed to being tethered into the wall. We've built Aqualith on a growing portfolio of patents exclusively licensed from College Park. As a matter of fact, this invention was recognized as the 2020 Invention of the Year at the university. My partner, Greg Cooper, and I are serial entrepreneurs. This is my fourth startup. So I sold my last company last summer to Smith's Group, which is a publicly traded London-based company. So Aqualith is focusing on this exploding need for energy storage. And as you can see, this is a very large market. It's growing pretty rapidly. Put this in perspective, by 2050, if you look at the capacity required in consumer electronic, or maybe electronic batteries just in general, there's 30,000 gigawatt hours required, which is equivalent of about 1,000 Tesla gigafactories in Reno, Nevada. Tesla spent over $4 billion on that factory. So 1,000 of those factories is trillions of dollars. We're coming into play by bringing breakthrough technologies to the market that's going to require less batteries and less battery making capacity to be able to service this demand. Next slide, please. Elon Musk probably states the value proposition that we have most succinctly. The limit of Tesla's growth, as well as the limit of many consumer electronic companies, especially with big energy needs, is the price of an affordable battery cell. Next slide, please. Our technology brings to market 4 very unique features that, when packaged together, offer a very disruptive product to the market. First, higher energy density. Our technology offers 40 to 60% higher energy density than what's available on the market today. The technology is low cost. We do not use any cobalt or nickel, so the cost of the raw materials is significantly lower than what's used today. The technology is very safe. We use aqueous electrolyte, which doesn't burn, so you don't see the type of issues that Tesla has when one of their cars has a short circuit in the battery pack and the car goes up in flames. And finally, the technology works at a very, very broad temperature range. The military is looking for applications at the North Pole to the equator, and our technology meets both those needs very well. We have publications down to minus 50 degrees centigrade, and we also have energy testing has been done in tropic conditions. Next slide, please. Geoff is Elon Musk and Tesla's subject matter expert on lithium-ion batteries. When he was in Maryland last year visiting Dr. Wong, this was what he said when he was exposed to the technology. Most creative battery chemistry he's seen in at least 10 years. So very, very strong endorsement. Next slide, please. Our commercialization strategy. We need one market to start with, and we've selected military, and we primarily are doing that because the Army Research Lab jointly owns some of this IP along with the University of Maryland. And the Army Research Lab, Dr. Wong's laboratory, and a local Maryland company, SAFT, are working on military batteries today. We've been invited to join that triumvirate as the 4th leg of the stool. And what we're going to be able to do is bring the materials that we will manufacture. We will sell those through to SAFT. SAFT will put them into batteries. The batteries will go to the military. The military will do all the validation testing. And then we'll have that data pack to be able to take with us as we continue to expand into other consumer electronics devices like smartphones, tablets, laptops, and then ultimately into electric vehicles. Next slide, please. The ecosystem and the customer base and really competitive landscape is pretty diverse. On the right, you see these huge deep-pocketed multinational companies that make up the lion's share of lithium-ion batteries today worldwide. All of those are Aqualith customers. On the left, this table is high technology companies that are making breakthrough innovation in silicon and lithium-ion batteries. And we look at all of those folks as being people that we can partner with in a synergistic way. They're typically focused on one aspect of the battery, and we can bring our cathodes, anodes, and electrolytes to market and help enhance their value proposition. It's interesting to note in the last 12 months, $16 billion has been invested in advanced lithium-ion batteries around the world. So lots of interest, and we're going to help support that industry as we grow our manufacturing base. Next slide, please. An example of, this is the first product we're going to take to market, our cathode material. And the reason we just started with the cathode is it makes up 40% of the battery cell cost. And what we're able to do is, since we don't use nickel or cobalt in our chemistry, our batteries right out of the blocks are 20% cheaper. And since we have higher energy content, a customer doesn't need as many battery cells, and thus there's not as much battery material required. And if you work through the math, there's a significant cost reduction available. And when you put that in context of the 2020 projected demand, there's $21 billion of either cost reduction or cost avoidance that we offer the industry if the entire industry were to switch over to our cathode materials. Next slide, please. Intellectual property. As I mentioned earlier, the technology was invented at the University of Maryland. It's jointly owned between College Park and the Army Research Lab. The Department of Energy and the Department of Defense have funded Dr. Wong's lab to the tune of $10 million over the last number of years. We have the exclusive license with worldwide rights to all fields of this technology. And we also have rights for new inventions coming out of his lab. We were excited 2 weeks ago to know that Dr. Wong was just awarded $5 million of additional funding from the Department of Energy over the next 3 years. So there's a very committed base of government sponsors behind this technology, and they're pushing both the University of Maryland and Dr. Wong very hard to commercialize the technology. That's where Aqualith comes in. We are the path to market. Next slide, please. Our financial projections. First couple years, we're going to spend a bunch of money, and the resources we invest are going to be building out our facility, our research labs, our prototype shop, hiring a team, writing grant applications, and making prototypes in scale that we can sample customers. In 2023, the commercial ramp up starts with revenue starting to flow. 2024, the slope of that revenue curve starts to ramp up dramatically. We're very excited with the relationships we have with the Department of Energy and the Department of Defense. Since they are pushing so hard to commercialize this technology, we are confident we're going to be able to secure a couple $1 million a year in non-dilutive funding through grants coming from those organizations. Next slide, please. We're on the homeward stretch of our raising a seed round. We're taking up to $2 million in seed funding. And with that, we're going to hire our technical team. We're going to establish a lab and prototype manufacturing capabilities, apply for grants, and start the initial production scaling process. Next slide. Key milestones. The end of 2021, we will have our lab started up. We'll have the technology transferred from Dr. Wong's research laboratory into our facility, and we'll be making small cells that we can make on a repeatable basis so we can get our hands around the technology, the processes, and the value stream that's associated. Middle of 2022, we're going to bump up the energy capacity of those cells that we're making by an order of magnitude. And by the middle of next year, we think that's going to lead us to opportunities to talk to the market in terms of mergers and acquisition discussions, royalty discussions, licensing discussions, as well as manufacturing scale up. So we think this can go very quickly, and it can turn into a very, very quick way of turning around an investment on the technology that's been made so far. Next slide, please. The team that's leading Aqualith, we're serial entrepreneurs. You heard a little bit about me. My partner, Greg Cooper, is a University of Maryland PhD in physics. He was the founder of Pixelogen Technologies. And as a matter of fact, Greg and I first met each other at 15 years ago, working in the TAP building over by the Verizon or the Comcast Center on our early companies in our career. We have Dr. Chongqing Wang, who's joining us as a founder. He is one of the lithium-ion battery experts in the world, and we're delighted to have him with us. We've started a scientific advisory board, of which Dr. Wang is going to be the chair. We've already added Dr. Cindy Lundgren, recently retired from the Army Research Lab, where she managed many of these battery development programs for them. We're in conversations with Dr. Mark Johnson, formerly of the Department of Energy, who's now a faculty member at Clemson University. And we have discussions going on in Western Europe with a former director at BASF that's there to help us with business development on the continent. We're surrounding ourselves with some high-powered advisors. We have George Davis, who used to run TEDCO at the state of Maryland, and Rick Kaur, who's the managing partner of Evergreen Advisors. They're helping us on the strategic advice side. Next slide, please.
We need to wrap up here.
So in summary, we have batteries that are technology that offers complete anode cathode electrolyte technologies. They're cost effective, they have higher energy density, they're safe, and they work at a broad temperature range. We have a team of entrepreneurs who's done this before, has the scars to show for it, and we're investing our own time and capital into making this happen. And finally, we're raising a seed round, and we're on the homeward stretch, and we're looking for, next slide, please. We're looking for partners who will join us on this journey. So can I take any